Hi everyone, I am Yudhveer Saluja and this is my independent research. The topic is alpha-mangostin downregulates FASN gene, induce apoptosis by increased expression of Cas3 gene and inhibits migration in MDA-MB231 breast cancer cells. To begin with, breast cancer is most diagnosed cancer among females and a leading cause of death. Due to low cure rate and high recurrence of breast cancer, studies are being conducted for drugs that induce apoptosis and delay tumor growth. The FASN gene is responsible for production of the enzyme called fatty acid synthase. It is generally in low levels in normal cells, but in breast cancer cells, increased level of FAS is linked to tumor growth. Due to this, reduction in FAS represents a potential treatment. Alpha-mangostin is a natural xanthoid found in Garcinia mangostana Linn. A plethora of reports on alpha-mangostin have demonstrated its use as a nutraceutical due to its anti-inflammatory, anti-tumor, and antibacterial effects. We hypothesized that treatment with alpha-mangostin will decrease cell viability by inducing apoptosis and by increased expression of Cas3. It will reduce the expression of FASN gene and inhibit migration. The objectives of this study is to analyze the dose and time-dependent effect of alpha-mangostin on cell viability, to investigate the effect of alpha-mangostin on FASN gene and Cas3 gene expression, and to also determine the effect of alpha-mangostin on migration of breast cancer cells. In this study, MTT assay, wound healing assay, and experimental qPCR was performed. The results of MTT assay were as follows. After 24 hours of treatment, there was significant reduction in cell viability at 4 micromolar, 6, 8, 10, 12, 30, 40, and 50 micromolar treatment doses. Similarly, after 72 hours of treatment, significant reduction in cell viability was observed at treatment doses 30 micromolar, 40 micromolar, and 50 micromolar. Coming on to experimental qPCR, the results showed that there was no significant reduction in gene expression of FASN gene, and similarly, it was revealed that there was not significant increase in the gene expression of Cas3. The results from wound healing assay was inconclusive due to the fact that the wounds induced in vehicle control and treatment groups were not healed, so the wound closure in treatment group and control group could not be compared. To conclude, the study explored the association between FASN gene downregulation, apoptosis, and migration of breast cancer cells after treatment with alpha-mangostin. Based on our results, we can conclude that alpha-mangostin significantly reduced the cell viability. According to the study conducted by Ping Li, and it is also uh, referenced, the results of Western blotting revealed the reduced fatty acid synthase activity. In using the study, it was hypothesized that Western blotting data would support the experimental qPCR in our study, but the results from our experiment do not align in the same direction. Similarly, it was also anticipated that the treatment with alpha-mangostin would increase the expression of Cas3 gene. However, there was no significant increase in Cas3 activity after treatment. Overall, the results from the experimental qPCR of FASN and Cas3 gene were unexpected. The results from wound healing assay were inconclusive due to the reason that wound induced in vehicle control samples did not heal. So, wound closure activity of MDA MB231 cells could not be compared with the treatment groups. Coming on to future directions, overall, there are still possibilities where development of xanthone as an agent can be used as the basis of breast cancer therapy. Our study adds a new therapeutic target for alpha-mangosteen in breast cancer and encourages the researchers to sight see this compound further. This study takes us one step closer to the possibility of non-invasive treatment of breast cancer. Now, I would like to express my gratitude towards Dr. Jessica Livingston, Crystal McFadden, Dr. Michael Gibson, and Marla McKenzie for their insightful feedback and continuous support. Thank you.